So, hello everybody. My name is David Halasz. I'm a PhD student slash researcher in my first year at the Lab of Software Architectures and Information Systems at the Masaryk University in Brno, Czech Republic. And I would like to present our position paper that we prepared with my supervisor, Barbora Buhnova. It's about rethinking safety in autonomous ecosystems. And I didn't write a table of contents. We can start going backwards in the world. So let's start with software ecosystems. So if software systems are getting more and more complex as they are forming organically, let's say, more and more complex structures, they become so-called ecosystems. We can we can look at them as software systems of systems that provide a richer set of features, much more advanced than regular systems, but of course with the cost of more complexity. If we look at it from the point of view of regular architecture, the architecture of a software system can be viewed as a plan of a building. Then the architecture of a software ecosystem can be viewed as a plan of a city. Some patterns are the same, some things can be applied one-to-one, but it's much more complex and it needs, in some things, different way of thinking. So if we put autonomy into this, so if we talk about autonomous cyber physical systems, they can also form a much more bigger unit called an ecosystem as a system of systems, which obviously provides a much higher degree of autonomy. If we take an example of a city where multiple autonomous vehicles can join or leave the system at any point of time, you can see that it has much more dynamics, a lot of complex changes, high number of uncertain and unpredictable scenarios. And my research part here is that it's very harder to ensure safe and secure behavior of such an ecosystem as a whole. We have techniques to ensure safety in systems, but those are not always applicable for a bigger unit of systems of systems. So we need a change of how we think about safety. At the very beginning of my research, I looked into what are the main key problems that needs to be solved. First one is to detect intent. So if I take an example of two autonomous vehicles meeting in an intersection, and one of them having a faulty component, so the other one can treat it as malicious because of that faulty component not saying truthful data. It can be behaving unintentionally malicious. And it's important to distinguish between this intentional behavior and unintentional, because ensuring safety would be different in a situation where the system is designed intentionally to do damage than having a system that just misbehaves by some mistake. Then the next one is connected to this is supervision awareness. So a malicious system in most of the cases shouldn't know that it's flagged as malicious. So if we look at the example of the emission scandal from a few years ago, some cars on a test bench were producing different kind of CO2 levels than in the real world. That's a great example of this awareness. We shouldn't let a malicious system to know that we know that they are malicious. But on the other hand, if a system is behaving unintentionally bad, then maybe letting it know can help correct its behavior. And the next one is misclassification. If we use any kind of method to classify if a system or vehicle or anything behaves maliciously, they will never be perfect. There will be always false positives that would say that the system is doing as it should, but it's actually not, and false negatives when it's saying that it's malicious, but it's actually not. And if we apply safety mechanism based on this classification, we can unnecessarily limit too much a non-malicious system or expose a malicious system to other vulnerable systems unnecessarily too much again. Then the next problem is feedback loops. So if system A starts treating the system B as hostile, and imposes some kind of safety mechanisms, then system B can react to this as something malicious and start also imposing some safety features. And these two things are, two systems can impose more and more safety features just because they are treating the other one as hostile because of their careful behavior, and this can even lead to a total halt in the system. Moreover, we can design a malicious entity that can disrupt the whole ecosystem just by being there and causing a feedback loop like this. And last but not least is compatibility. If we talk about, again, autonomous vehicles, different vendors, different manufacturing software, they need to work together somehow, even though they not necessarily have the same kind of safety features. Also, an edge case is when we have human drivers as well, which don't have any software. So I was looking into related research in the field around autonomous vehicles and safety. They are dealing mostly with the safety of an individual vehicle and not as an ecosystem as a whole, except like vehicle platooning and some collision avoidance things. But most of the research isn't around like the whole city or like the whole region where all these autonomous vehicles behave as one big thing. Then a very promising idea was simplex architecture, where we have a working system, a normal system, and a failsafe that would only turn on when there is something wrong. But this kind of solution isn't really handling well uncertain situations, and we would need to chain a lot of simplexes together. And again, this applying it to larger ecosystems across different entities is problematic. Regarding self-adaptation, so I was doing some experiments with make-gate feedback loops, but here again, we not necessarily want to share that much information among different autonomous vehicles or any autonomous systems, that we would create make-gate feedback loops among different devices. In the topic of distributed ecosystems, well, wireless networks, mostly ad hoc networks, solve this problem well in certain cases, but there the issue is that they only deal with the cyber part, so they can like cut off a node from a network, but we still have the physical part, so even if we disconnect something from the network, it can do harm in the physical world. And maybe that triggers the problem of supervision awareness, because the node would detect that, or the entity would detect that it's cut off from the network and behave accordingly. And I was looking into various research around classification of behavior, mostly models at runtime and modeling in general. But there the issue again is sharing, that we not necessarily want to communicate the model of our device with other devices because they can use it against us. So with my supervisor, we are proposing a solution to use trust as the base of decision, as a decision factor. So a trust quantification method has to be trust as in humans perceive trust, not as trust in like cryptography when you trust using certificates. So a trust quantification method would require a non-binary output that wouldn't just give us true or false, but a spectrum of values like a percentage or a number, or even like a multi-dimensional thing. We would evaluate this trust real time among member systems, both event and time triggered. We would consume both trust directly and also reputation spread by other members. So if another node has trust information about other nodes, we could somehow aggregate that as well. And based on these values, we could dynamically toggle safety features and expose any kind of services to other nodes. Simply said, we need a granular trust or in general classification method and a gradual safety that's based on this trust output. Based on that, scrolling isn't really the best. So based on that, we would like to construct some kind of safety assurance framework, which would take some inputs and some reputations coming from the real world. Using the trust model, we would calculate the trust value, which would be propagated as a reputation for other actors. A safety module would consume this trust and using the decision tree, either enable some features or disable them and also trigger some safety mechanisms or untrigger them if the trust value is a certain number, if we talk about numbers. This is in a very early phase of research. We started working on this last November, October. So in the future, we would like to do a proof of concept implementation and validate it using models. And we have the unique situation of having like 5 or 6 autonomous vehicle manufacturers in the region. So we'd like to reach out to them to do more validations. Our focus is mostly on autonomous vehicles, but I believe that this can be generalized and help to think about safety differently. Thank you for your attention.
Thank you very much, David, for the presentation, and I open the discussion. If there is a question about this very interesting presentation.
So I have a question. Since you talked about trust, how do you define trust? And is there a quantitative method like a formula or something where you could take a device and say, I can quantify this device and it is that trustworthy or not, and compare it to another device? I was late for the talk, but I'm just interested in the trust definition in general.
Yeah, so trust is not actually my part of research. I'm only consuming trust. I have some other lab members who are working on more like the modeling. We are doing like surveys on different trust models. Problem is that I cannot give you one definition of trust. Each field defines it differently, and as we're chewing ourselves through all the papers, they interpret trust slightly differently, depending on what other field of science they use as inspiration.
Yeah. I just want to add, so if you look at the trust today, do you trust in the same as time goes by?
No.
So for example, is there like a time component to trust?
Yeah, so there's a recalculation in the framework, both event-driven, so if something happens in the ecosystem, and also time-driven.
I have one question to you, because the very important for your model is the communication model between the nodes. What kind of communication do you plan to implement in the proof of concept which you are mentioning about? Because the autonomous system have to communicate each other, I suppose.
Well, I suppose if we work with autonomous vehicles, it has to be some kind of ad hoc wireless network.
Okay.
If that answers your question.
Okay, so you don't choose any specific method to communicate, as low energy or Wi-Fi or
probably 6LoWPAN. Okay, so we have some people at the lab working already with 6LoWPAN and like finding malicious nodes. And if we can use the network to do things for us, then obviously we will do that.
Okay, thank you very much.